on to question 6. What are polar and nonpolar bonds? Okay, so I'll just write out the definitions for both. A nonpolar bond contains two atoms that have equal or even just similar electronegative values. And then I'll just write the definition for a polar bond, which is, as you can assume, the opposite of a nonpolar bond. So the atoms have dissimilar electronegative values. Okay, so I'm going to write out some examples, and I'm also going to just Google an electronegativity value periodic table. Just so that we can show all of them. This one's a bit clear. Okay, so I'll have some examples for a nonpolar bond. So nonpolar bonds generally have an electronegativity difference that is equal to 0 to 0.5. So let's say we had a diatomic molecule such as N2. If we were to calculate its electronegativity, its difference in electronegativity for this bond, let's look at our table here. It would be 3.0 minus 3.0, which is equal to 0. So therefore, a nitrogen-nitrogen bond is nonpolar. So let's have another example where we have like a carbon-hydrogen bond. If we were to calculate its difference in electronegativity, carbon is right here, so it has an electronegativity value of 2.5, whereas our hydrogen up here has an electronegativity value of 2.1. So the difference between the two is only 0.4. So therefore we can say that the carbon-hydrogen bond is also nonpolar. Okay, so let's look at some examples for polar bonds. So when you have a polar bond, basically the difference in electronegativity is around 0.5 to 1.69. And I'll also note that polar bonds are between two nonmetals. Well, any polar bond is between two nonmetals. Same with the nonpolar bond is between two nonmetals. So every time if you see a metal and a nonmetal, this is referred to as an ionic bond. So if you see a metal involved, you already know that it will be ionic. You don't even need to calculate its difference in electronegativity. But going back to the difference in electronegativity for ionic bonds, its difference will be greater than 1.7. So like I mentioned before, atoms have a dissimilar electronegativity values, and because of this, it leads to something called a dipole moment. Okay, so some examples would be like the oxygen-hydrogen bond. If we were to look at its difference in electronegativity, oxygen has an electronegativity value of 3.5, and hydrogen is 2.1. If we were to calculate its difference, it would be 1.4. So therefore, the oxygen-hydrogen bond is polar. So I can draw out a water molecule, and because the oxygen is more electronegative than the hydrogens, it creates a dipole moment in the water molecule, where the sides with the hydrogens are slightly positive and the oxygen is slightly negative. So this is an example of a polar molecule. Okay, so we can look at just one more example of a polar bond. Let's say the phosphorus fluorine bond. The electronegativity value of fluorine is 4. It is the highest electronegative element on the periodic table. And for phosphorus, it is 2.1. So already we can see that they have a difference of around 1.9. Yep. So this is a very polar bond. So notice that it is between two nonmetals. So let's see what the junior tutor said. The polarity of a bond depends on the relative electronegativities of the two atoms sharing electrons. Electronegativity dictates if the partial transfer of electron density from one atom to another is possible. When the electronegativities are not equal, electrons are not shared equally. This results in the development of partial ionic charges. In definition, the greater the electronegativity difference, the more ionic the bond is. Partially ionic bonds are called polar covalent bonds. On the other hand, that having equal share of electron between two atoms and has electronegativity are called nonpolar covalent bonds. Okay, so they have a summary polar covalent bonds. between two nonmetals that have different electronegativities and therefore have unequal sharing of the bonding electron pair. For example, the hydrogen and chlorine bond, electronegativity of chlorine is 3, while that of hydrogen is 2.1. The resulting bond is where an electron pair is more displaced towards the more electronegative atom. The atom with more electronegative gains a partial negative charge, while the less electronegative atom has a partially positive charge. This separation of charge is called the bond dipole. For nonpolar covalent bonds, this is between two nonmetals that have the same electronegativity and therefore have equal sharing of the bonding pair. In hydrogen-hydrogen, they have an electronegativity value of 2.1, therefore the covalent bond between them is considered nonpolar. Yep, so this solution is correct. I'll just also add that for nonpolar bonds, if okay, so I also just added a note that for non-polar covalent bonds, they don't necessarily need to be equal, like exactly equal. They just need to have an electronegativity difference less than 0.5. But the solution is still correct.